Okay, so we're going to continue with section 4 of our unit on reactions in aqueous solutions, talking about another type of reaction called an oxidation-reduction reaction. So far we've talked about double replacement, acid-base, and now we're going to talk about oxidation-reduction. Sometimes these are called redox reactions. It's a little bit easier to say than oxidation reduction, and then you've got your oxidation part here and your redox part here. So redox reaction involves the transfer of electrons. So electrons are moving between reactants to products, or from reactants to products. Usually it is a reaction of a metal and a nonmetal, and then we form an ionic compound because that's what a metal plus a nonmetal is. It's an ionic compound. Usually, well, not even usually, always, the electrons will transfer from the metal, which remember is the cation, it's the positively charged ion, to the nonmetal, which then becomes the anion, or the negatively charged. So we're taking electrons from the metal, making it into a cation, and we're giving those electrons to the anion, giving them to the nonmetal, making it an anion, or a negatively charged ion. So for example, if we take sodium metal and chlorine gas, it'll transfer electrons, making sodium the +1 ion, and so this is our cation, and then the electron was transferred to the chlorine, making it the anion. So it's a transfer of electrons. This type of reaction can also take place between two nonmetals, and we'll talk about that when we get more in depth to redox reactions, or when and if you take AP chemistry, but for our purposes it's pretty much a metal and a nonmetal. Okay, so let's look at an example. So we have a reaction of magnesium metal with oxygen. So we have magnesium, it's a metal, so it's the solid. This should say that it's traditionally going to be oxygen gas. And so we know, because oxygen is a diatomic, that it's O2 and it's a gas. Well, we know the charge on magnesium when it becomes a cation is 2+, and the charge on oxygen when it becomes an anion is 2-. So to write a neutral compound, one of each of these is sufficient because it's 2+ and 2-. But now we need to make sure we have a balanced equation. Since I have 2 oxygens from my O2 gas, I'm going to put a 2 out front. That means I have 2 magnesiums, and so I'm going to put a 2 there. Now I have a balanced reaction. So now what we want to do is write what are called half reactions. One half reaction shows the formation of the cation, and then the other half reaction shows the formation of the anion. So we have our half reaction for our cation, and then our half reaction for our anion. Okay, so we know magnesium is the metal, it's going to become the cation. Here it's a neutral element, so it's going to lose 2 electrons to become that cation with that 2+ charge, and we would say that it is oxidized. So that's the oxidation part of our oxidation-reduction reaction. So to show this, we're going to take our magnesium. Since it's losing 2 electrons, it's going to go to magnesium 2+, it's going to form the cation, but we need to account for those 2 electrons, and so we make them as part of the product, because they were removed from the magnesium. So they're listed as a separate product. So that's one half reaction. Okay, the other half reaction is the formation of the anion. And so this is going to be our oxygen, since it's gaining 2 electrons. When something gains 2 electrons, we say that it is reduced. So if you think about electrons, they're negatively charged. So if you're gaining something that's negative, it makes your charge more negative, so it's like you're being reduced because you're becoming more negative. And so that's kind of how I remember that. And then I just know that the formation of the cation is then the oxidized, or the oxidation part. And so since oxygen is gaining 2 electrons, we have our O2. It's going to gain 2 electrons, and that's going to give us, and I suppose we could balance this also, 2. And then we're going to add 2 electrons, and so that's going to give us our 2O2-. Okay, and so we've gone from O2 as a gas, neutral compound, gaining 2 electrons to produce 2- ions. So these are what we would call our half reactions. This is oxidized because it lost electrons, and the oxygen is reduced because it gained the electrons. Okay? Okay, so I would like you to try the same thing. I want you to write the two half reactions for the reaction of aluminum metal and chlorine gas. So let's write the first part together. We know we have our aluminum metal, and we know we have chlorine gas. Now chlorine is also a diatomic, just like oxygen, so Cl2. And that goes to, we know aluminum forms the 3+ ion when it goes from a neutral element to the ion, and chlorine forms the 1- ion. So to make that neutral, we need 3 chlorines. Last thing we need to do is balance it. Because I have 3 chlorines on my products and 2 chlorines as my reactants, I need 3 Cl2s and 2 AlCl3s, which means I also need 2 aluminums here. Okay, so write the half reaction for the formation of the cation, and then write your formation write your half reaction for the formation of the anion. Okay, and we'll check these answers in class. Have a good day.